So far we've looked at some basics of game theory and looked at how spatial thinking can help tell us how a particular politician decides whether to vote for or against a bill. In this module, we'll look at how to determine whether a majority of politicians vote for or against a given policy. Let's start with our example of the minimum wage and examine a small 3-member committee that votes according to majority rule. Minimum wage policy fits pretty nicely in the policy space we talked about before. We can just start by drawing the line and put lower minimum wages on the right and higher minimum wages on the left. Now let's define some players. Suppose Lorien, Parker, and Riley are in charge of minimum wage policy. The current minimum wage is $8 an hour, so that's our status quo. And the preferred minimum wages of our 3 players are $7, $9, and $11 an hour respectively. Let's think about some different possible minimum wage proposals and think about who would vote for each. What if Lorien proposes to move the minimum wage down to $7 an hour? Who would vote for that proposal? Well, obviously Lorien would, because that's the best possible policy for Lorien. But Parker and Riley don't like a $7 minimum wage. It moves the policy further away from them. They're worse off with a $7 wage than an $8 wage. Take a look at Parker's loss function. As the minimum wage moves down to $7 an hour, Parker's utility falls further. Parker's better off at $8 than at $7. And what we learned from this example is that nobody likes to vote for a proposal if it moves the status quo even farther away. If you think the current policy is too conservative, you're not going to vote to support a policy that makes the law even more conservative. What if Riley proposes an $11 minimum wage? Will Lorien vote for it? Well, no, the status quo of $8 is already higher than Lorien wants, so moving it up to $11 is even worse. But what about Parker? Well, take a look at Parker's loss function. The status quo is only $1 off of Parker's ideal, and moving it up to $11 an hour would make it $2 away. So even though Parker thinks the current minimum wage is too low, the $11 an hour proposal is just too high, and Parker prefers the current level to $11. So what bill might Riley suggest? Riley's going to propose the biggest increase that can pass. How can Riley figure out what to propose? The key here is to figure out the rule. Remember, the committee uses a majority rule, and in a majority rule, the key figure is the median. In fact, in games like this, there's something called the median voter theorem that guarantees that whatever policy the median voter votes for, that policy wins. So where do we find the median? The median, as you may remember from middle school math, is the player right in the middle of all the other players. In this picture, Parker is the median. So Riley needs to get Parker on board to pass a new bill. And what bills will Parker support? Well, we looked at a question like this in the last module. Start by looking at Parker's loss function. The current status quo is $8 an hour. Parker would like it to be $9. And Parker will vote for any proposal that offers at least this much utility. We can draw the line over and then up and see that Parker will vote for any bill that proposes a minimum wage no more than $1 away from the $9 ideal policy that Parker likes best. It's worth stopping for a moment to remember that this happens because we made a symmetry assumption. We assume that Parker only cares about how far away the minimum wage is from $9. The direction doesn't matter, whether it's higher or lower. Now we're going to keep this symmetry assumption for the whole time we do pivotal politics. And when we have this symmetry assumption, it's easy to figure out how far Parker will go. To find the largest increase that Parker would support, we flip from the status quo point over Parker's ideal point like this. Parker will accept anything between $8 an hour and $10 an hour. Now, you may be asking yourself, why doesn't Parker just promise to vote against any policy other than $9 an hour? If Parker can just hold out and veto any proposal other than $9 an hour, and we allow the game to go on and on and on, eventually Parker or Riley will offer $9, which is less than Riley was hoping for, but it's better than $8, and it's the only thing that Parker would agree to. Once Parker gets the $9 an hour minimum wage, the game ends. Parker would never vote for anything other than $9, and neither Lorien nor Riley can move it without Parker. Of course, that kind of logic happens all the time, but in pivotal politics, we assume that there's only one shot at any proposal. When the proposal comes up for a vote, it's a take it or leave it kind of deal. One player gets to make the proposal, and all the other players have to choose whether to accept or reject. But either way, the game ends once they decide. These games are great for the proposer, since the proposer is the one who gets to offer the ultimatum. And by the way, this type of game is common in game theory and the growing field of behavioral economics. It's called an ultimatum game, and it's at the heart of the pivotal politics model. Because it's an ultimatum game, Parker can't credibly promise to vote against any proposal between $8 and $10. Suppose Riley gets to propose a $9.99 an hour minimum wage. Parker won't vote against it, because if this proposal doesn't pass, there won't be another one. And Parker's stuck at $8 an hour. So if Parker has to choose between a $9.99 minimum wage, which is 99 cents away from the ideal point, and an $8 minimum wage, a full dollar away, Parker will take the penny improvement and support the bill. Now we're going to use these tools to look at actual politics, but before we look at an example in the Senate, let's take a quick look back at what we've covered so far. First, we're thinking about games, so we need to know who the players are, what they do, their actions, and what their payoffs are. We need to start at the end and work backwards, that's the backward induction, and we need to pay careful attention to the rules. And we assume that players have spatial preferences. That is, the further away from their ideal policy, the worse off they are. Finally, we assume the final vote is a take it or leave it offer, so players will vote for a policy if it will make them better off, and vote against the proposal if it makes them worse off. But we also looked at something called the median voter theorem that says when we vote according to majority rule, the bill passes if and only if the median votes for the bill. So let's try this out in the Senate. Final passage of a bill in the Senate is by majority rule. There are 100 senators. But let's assume that there are only 99 senators there today. That gives us an odd number and makes finding a majority easier. A bill passes if it gets a majority. That means you need 50 senators to pass. If we put the senators on a line like this, we have a start. Now we need to figure out where the status quo is and where the proposal is. We'll talk about where to pin these things down later, but for now, let's assume that the status quo is here at Q and the proposal is here at P. We want to figure out who's going to support the proposal and who prefers the status quo. The first thing we notice is that the proposal and the status quo divide the policy space. Remember, the policy space is what we call this line. It's where we can put policies and politicians and figure out who's on the right and who's on the left and who votes for what. And these points, the P and the Q, will divide this policy space into three parts. Let's look at the part of the line past the point marked P, where the proposal is. These are all the senators whose ideal points are in this region. Are they going to vote for the proposal or against it? Remember, they're choosing between P and Q, and thinking spatially, they will vote for whichever point is closer to them. Now, clearly, they're all going to vote for P. Every senator in this region is closer to P than to Q. Now, what about all the senators on the other side? What about these senators here? Are they closer to P or to Q? Of course, the answer is Q. Well, now let's focus on the senators in the middle section. Let's look at a couple. What about this senator? Closer to P or closer to Q? How about this senator? Now, what about this one? Think about it for a second. Can you think of a clean and easy way to divide up this middle section between senators who vote for P and those who vote for Q? The easiest way to do this is to think about the point that is just as far from P as it is from Q. And if you find that point, then any point on the P side of it prefers P, and any point on the Q side prefers Q. And the point that's the same distance from P as it is from Q is the point halfway between them. This midpoint is called the cut point, or cut line, because it cuts the policy space in two, with everybody on one side voting one way and people on the other side voting the other way. So if we want to know whether the bill passes or not, we need to know whether there are more senators on the proposal side of the cut point than there are on the status quo side. There are two ways to do this for our purposes. One, we can count them, but that can take a long time. For instance, the House of Representatives has 435 members, so it's not all that efficient to manually count everything. The faster way is to remember the median voter theorem. When the vote is by majority rule, the median voter is pivotal, and so however she votes, that side is the winner. So instead of counting, we just have to find Senator number 50 and see which way she votes. Well, let's look. Here's Senator 50, and she's on the proposal side of the cut point. So the bill is going to pass. Here's one more example. Suppose the status quo is here, and the bill proposed falls over there this time. Pivotal politics doesn't care whether the proposal is more progressive or more conservative, so this time we flip them around. Once we have the status quo and the proposal, how do we find the cut line? Remember, the cut line is the point right in the middle between P and Q. If the cut point is there, who are the friends of the bill? It's this group on the proposal side of the cut line. Now let's add in the senators. Does this bill pass? How do we know? We look for the median senator, number 50. Well, there she is. This time she's on the Q side, so the bill doesn't pass. The idea of the cut line is actually pretty flexible. So far we've figured out where the cut point is by looking at the point halfway between the status quo and the proposal. But suppose you and a friend are arguing about how conservative a law is. Suppose you both agree that the status quo was here, a little to the left of center. Then you watch the Senate vote on the bill, and you see this voting pattern. All of those blue dots to the left voted for the status quo, and all of the red dots voted for the proposal. Where is the cut point? The cut line is the point that cleanly divides the blue from the red. It's about right there. Now it's easy to see where the proposed bill was. Remember, the cut point is halfway between the status quo and the proposal. So if we flip the status quo over the cut line, we land over here. This is our best guess as to where the proposed bill was. It's where we think the P should go. We're going to spend more time in a future module working on strategies to figure out where the proposal is located. But you can see from this example one way to figure that out. Okay, that's everything for this module. Take a crack at the following review questions, and I'll see you at the next module.